Tangent secant family. Recall tan squared plus 1 equals secant squared. We're going to be integrating trig products of the form tangent to a power x times secant to a power x dx. And this is going to be the same thing for the cotangent cosecant. The only difference is instead of tangent you would have cotangent, instead of secant you would have cosecant. Alright, case 1. If m is odd. So here's an example. We have integral of tan cubed x secant to the 5th x dx. What we're going to do for this one is separate a tan x secant x dx. So we will take one tangent out of there, we'll have 2 left, and we'll take one secant out of here, and we'll have 4 left, and we have tan x. In fact, let me write this as, just so it looks a little bit easier, secant x tangent x dx. Now, why would we want to do that? Because we can see that this is the derivative of secant x. What we'll do now is substitute the remaining tangent squareds with secant squared x minus 1. So I have, in this case, just one tan squared. So we'll change that to secant squared x minus 1 secant to the 4th x times secant x tangent x dx. Next step, integrate by substitution. What will our substitution be here? I've already basically said it. Let u equal secant x, and then you'll find du and continue on. So over here, let u equal secant x, du is secant x tangent x dx. Substitute it in. We don't need to multiply this out at this point. And we have u squared minus 1 times u to the 4th times du. Now we can multiply it out. We'll have u to the 6th minus u to the 4th, which those are now simple polynomials. So we have 1/7 u to the 7th minus 1/5 u to the 5th plus c. Substitute back in. We get 1/7 secant to the 7th of x minus 1/5 secant to the 5th of x plus c. And that's it for that one. Let's go on to the next case. If n is even, so note in both of these examples we're not saying what the other power is. The focus here is just the fact that n is even. What we're going to do this time is separate a secant squared x. So we'll take this and separate out a secant squared. So we'll have secant squared times secant squared dx. Substitute. Hopefully it's starting to be clear even before I write this next part. Substitute what? The remaining secant squared x with tan squared x plus 1. Again, that's our identity we reviewed. So we'll come over here and we say instead of this secant squared, we'll say tan squared x plus 1 times secant squared x. Next step, we are going to integrate by substitution again. And hopefully that's becoming clear. Why did we separate out the secant squared? Because that is the derivative of tangent. So we're going to say with u equals tan x, and then we'll find the du, etc. So let's apply that to this problem. Let u equal tan x, du is secant squared x dx, and let's substitute in. If we have u squared plus 1 times, that is du, and then integrate that. This is pretty straightforward. And you can see if we had a power here, if it was squared, then we'd have to square this out. If it was cubed, we would cube it out, and then just go ahead and do the integration of the resulting polynomial. So the antiderivative of u squared is 1/3 u cubed plus u plus c. Substitute in what u, so that's tangent cubed x plus tangent x plus c. Now the third case. The third case is the hardest one because we don't have as easy a nice simple formula that we could follow. We have if m is even and n is odd. This one's hard to tell. There's no hard and fast rule we can say this is going to definitely work. We can try something like integration by parts and see if that works. So what would we do here? Let's take a brief moment to review integration by parts. The integral of u dv equals uv minus the integral of v du. So we're going to have to break this up into two parts, and one of those is going to be u and the other will be dv. Now we always can find our derivative. Now we want to break it up into something where we can find an antiderivative of it. Well, this one's not too bad as far as applying this because secant cubed can only be broken up into secant times secant squared, as long as we're looking at just two things multiplied together. So that would dictate that u is secant x and dv is secant squared x dx. Find du. We have secant x tangent x dx, the derivative, and then v, the derivative of what is secant squared, tangent x. So we just have to make sure that we remember to be careful about what we're finding the derivative of and what we're integrating. What I do on this one is let's set this equal to I as well. So we'll have I equals uv, u and v, so we have secant x tangent x minus the integral of v tangent x times du, which is secant x tangent x dx. Simplify that, we'll have tan squared x times secant x dx. Now how do we integrate this thing? The best thing to do is you could stop the video and you try to do this before I go through with it. But this is what we just did. So what do we have here? Oh, actually, no, it's not what we just did. It's similar. We have here a tangent squared and a secant. Sometimes some might try to do another integration by parts. What would end up happening to that is you would undo what you just did. What could be done? When I'm looking at this, I see the only thing really here is tan squared. So what is our identity for tan squared? That is secant squared minus 1 times secant x dx. If we multiply that out, we get secant cubed x minus secant x dx. Is this good, bad, or ugly? What do you notice about this? What is our original question? Our original question is secant cubed x. That's exactly what we have here. This is secant x tan x minus the integral of secant cubed x plus the integral, don't forget the dx, of secant x dx. This is I. Let's take this I and we'll move it to the other side, which is one of our cases when we did integration by parts. So we'll get 2I equals secant x tangent x. Now what's the antiderivative of secant x? We did that one in the trig substitution. That was the first example number 3 in trig substitution. So if you want to review that, can go back to there. That one is the ln of the absolute value of secant x plus tangent x. Divide by 2, so we get I equals 1/2 secant x tangent x plus 1/2 the ln of the absolute value of secant x plus tangent x, and then write plus c, and that is it. So remember, if you get the cosecant cotangent, it's the same basic thing. You're just going to, instead of doing the substitution for, let's say, tan squared, you're going to do it for cosecant squared. Instead of doing it for secant squared, you would do it for cosecant squared. And that's it for trig products involving tangent secant.